Let's see, today is Tuesday, August 6th, 2019, and this will be Module 14, which is the last of our modules. And I don't have anybody else logged in yet, so I think I'm going to pause the recording for right now until some more people show up. So I'm pausing for just a minute. Recording. Let's see, this will be the last of the last of the modules that I generally use. So this is let me get back to there we go. This is module 14, excuse me. And this is the last one that we have. After this, all we have is the final exam. The final exam, again, I will have I promise you, I will have this test 2 graded and returned by tomorrow, by the end of the day tomorrow. And so I need to do that so that you can make a decision. So the final will be an optional final. Let me see. Do I have I don't have a practice test set up for the final, a practice exam, but you won't find it to be difficult. It is designed to be a grade raiser. And so if you haven't done well on one of the tests, then you would take the final. Let's see. That's I wanted this. We can get through this fairly quickly. Is it fairly clear what I'm wanting you to do on the indexing assignment, Ganesha? What do you think?
I'm a little behind, so I haven't really gotten the chance to look at it.
Okay, on the indexing assignment, I'm asking you to create some indexes. And creating indexes is pretty easy. It just says it's create index. You give it a name. I usually either append, some people will put it at the beginning, some at the end, but the term IDX tells you that that's an index. So you give it a name, and I can see that it's an index. Give it a name, and from that, you just create the index on, and then you give create index on, and then table name dot field name. It's pretty easy. Then boom, there it is. So where do you create indexes? You create an index typically on foreign keys. Foreign keys are a good place to put one. There are other things that you'll use. So when you create an index, you're telling me that this is a field that you think is going to be hot. It's going to be used a lot. So if you create an index, now some of them I wouldn't create an index on. For example, under, let's see, a foreign key, default terms ID in vendors would not be a good index, even though it is a foreign key into the terms table. It's a foreign key, but that doesn't necessarily mean it's a good index, because there aren't very many terms IDs in that table. There's only 5 or 6 of them. So you're not going to get very many of these. Also, terms ID in invoices would not be a good index. Other things would be the vendor ID, of course, is a good one for an index. Others could be, you might index the vendor phone, for example. If you did, then you're telling me that you're going to be using that a lot in your business plan. You're going to be searching on that a lot. And if you tell me that, then okay, I believe you, I would not index, what would I not index? I wouldn't index the payment total. Now, I mean, am I ever going to be, I want to see all of everything sorted by payment total. Well, maybe I do, but how often will I really be doing it? So there's some things that I'm not going to index. Account description, I would not index because that might be big. So I'm asking you to just design some indexes. We'll create indexes for this database. save it as an SQL file. And I would like to see 4 or 5 of them created. That would be good. So I don't think I tell you exactly. I didn't say how many, but basically it's just be create index and give it a name. And so this one you can knock out pretty quickly. What's my, got 40 points on this one. So, you know, pay attention to it, but it's, okay, now I'm going to go on to the next module. So the last module, this will be the last module that we're going to do, and I'm going to have one more time that we'll meet on Thursday, and then I'm going to try to wrap everything up. So let's see, objectives. I think I have this one here because I have to have the objectives listed. Close these down. Student resources, okay, I'm just going to start with the DB Design 1, database normalization, and this is a pretty good video. I believe it will play. Let me check it and make sure it's not a broken link or something. No, it isn't. Okay. Okay, 6 basic steps are identify the data elements. Now, this use a term here. I say the process is heuristic. Heuristic says I have a way of approaching it that usually gives us a good result. Where a heuristic is different from an algorithm. If I apply an algorithm, it always gives me an answer. A heuristic usually gives me an answer. So it's usually done by hand, and it's usually done by somebody that understands the business. So I have to understand the business before I can identify it. And I'm going to go out and I'm going to look at my clients. So somebody's paying me to design this database. I either work for someone or they've hired me to design the database. Either maybe I'm consulting. I design a lot of databases for churches, or I used to do more. It has become very tricky now because the data in a church are very private, obviously. So I'm not allowed to see the data. So I need to have some fake data that I can look at. So this invoice that's used, usually this is how they do it. So I say, okay, Acme Fabrication Incorporated, how do you do this? Okay, let me see a copy of one of your invoices. And I look at what's on it. Okay, there's an invoice number right here, an invoice date, the terms, their address, the phone number and fax and all that. This is probably the address of Acme Fabrication. That would be my next question is that the address of Acme Fabrication or the address of the of where this is going? Oh, I see a few more people have joined us. Am I recording okay? I mean, am I getting out? I see my, okay. I see my microphone icon is bouncing, so I guess I am. Okay, what else is here? Part number, quantity, description, unit price, extensions. Okay, so the extension, I don't need to have the extension. So I'm going to sit down and these are I make a list of what's on here. The vendor name, I'm going to guess I guess this is the vendor name up here. I'm going to guess that this is the address of the vendor. This is the invoice number. I don't know what my company is, but that's okay. I guess I could ask somebody. Got the salesperson and the accounts receivable. And all this from here, let's see, the part number, the quantity, description, unit price, the extension is, well, it's 12 times the unit price. So obviously I don't need to store the extension in my database. I don't need to store 12 times 100 in my database if I have the 12 and I have the 100. Okay. So let's see what's on here. What did they say is on here? The elements are the usual stuff: name, address, phone number, invoice date. Item extension, we're going to get rid of that one. Vendor sales contact name, and the invoice total. One other thing I would bring up, we don't need and should not store the invoice total. Now, if you look at our database, we store the invoice total. And I believe I brought this up and mentioned it before. That's a very bad design decision. And I don't think that the person who wrote the textbook is really that knows that little about a database that he or she would, actually I'd say he, would store the invoice total in the database. That doesn't make any sense at all. Why? Because the invoice total is the sum of the line items on the invoice. So I don't want to have it, it's the sum of these extensions actually. So identify the data elements that we want. So what would I keep here? Well, I would keep all of these: the name, the address, the phone number, the fax, maybe the web address. So this stuff would be somewhere in my database. Okay, so these guys right there, there's my vendors table, or a good part of it: vendor name, address, phone number, invoice number, invoice date, terms. Now these guys, these item things down here, these are the invoice line items, items extension. Some things I would get rid of: the vendor sales contact name, maybe I'd keep that. Okay, the extension right here, where to call him, maybe I keep that. I don't know. I just have to talk to them about it. Vendor accounts receivable, I'd probably lose that one. Invoice total, I'd definitely lose. Let's see what they've got here. As I identify the data.
Why would you lose the accounts receivable contact?
Oh, I might. One reason I would, because I've looked ahead and I see that they do. I mean, yeah, why would I? There's no particular reason I would or I wouldn't. I just know that this particular one does, so I'm just going to go ahead and say I would. The things that I would lose would be item extension and invoice total for sure.
Well, can I ask this question? Mm-hmm. I guess what are we looking at this from the perspective of information that you would download from the invoice every month versus information that you would store in your database, mm-hmm. but just not necessarily update monthly? Because
well, let me take that one.
Can see definite reasons to keep those contacts, but not have, you know, if you were using some sort of optical recognition software, I wouldn't waste time processing invoices to look at that accounts receivable person every time, but I'd still want to store them in my database, like maybe just update it every year.
Let me jump in here. We're not taking stuff off of this invoice to put into our database. Our database is going to replace this paper invoice. So our database will generate people aren't even generating paper invoices anymore. So this is going to go straight to the, in this case, the account that, I guess this would be a bill. So we're going to get rid of this. So everything is going to be in the database. So the database is going to replace this stack of paper invoices that we have in a file someplace. Now I'm going to have to scan them in, yes, which that's always a problem. But we're designing a process that does what this paper invoice used to do. Okay.
So we're talking about how for a big company we're going to receive the invoices in like an EDI type. We're trying to use
Right.
the database as you would EDI. Okay.
Sure. Assumably, they would be coming in somehow, and that's almost certainly a web page. But that's we don't know how they're coming in. They're just coming in for right now. But yeah, it'd be a web page. Okay, let me go to the next one here. Subdivide each element into its smallest useful component. This is pretty straightforward. I'm going to go close the door. I see I have a television in the background here, so I'm going to close my door. Keep the cat out of here too. Let's see. Person's name is stored as a single field. This is the typical example. Sales contact name is a first name, last name. Almost always I'll want a name broken down into some last names. Address divided into its components. This is what we mean when we say that to be in the first normal form, 2 or 3 things have to happen. First normal form, and that's what I'm going to talk about some tonight, is that data are accessed by content only, and we never talk about the first, the second, and the third record, which of course isn't always true because we studied this SQL construct called top 10. Well, if I talk about top 10, I'm violating that first normal form. Let's see. The data accessed by content only, and the second one is that a field has one and only one value. So this is a field that does not have one value, and it's got 2 values, first name and last name. Now, if I'm always going to use these 2 together, for example, I have a description of of something I'm selling. I'm selling sporting goods, and one of the things I've got is a BB gun. I don't have to separate out BB and gun because I'm never going to talk about one without the other if I'm talking about the part that I'm selling. On the other hand, a person's name, maybe you'll always talk about this person's name to get, Reuben Goldberg. Maybe it makes no sense, never will, for you to ever split it up. If that's the case, you can leave it together. An address, most of the time, addresses you will want split out. Why? Because if you sort things by zip code, you get a lot better mailing. If you're mailing stuff, you can take them down sorted by zip code, you get stuff a lot simpler. I would never store California. I would always store it as an abbreviation. I might store it as an abbreviation and then have that referencing a table with the names in it so that I can pull up the name very quickly. So would I break out the street and number here? Not usually, not usually. I might, if I had a telephone, I might break depending on how I would use that telephone. I might break out the area code, the first 3 digits. It has finally dawned on me that students today, young people in college, don't know what an area code is. What do you think?
I've heard you mention that, and I guess, yeah, everyone's just used to 10-digit dialing.
Yeah. It has become, we've lost the difference that an area code is something different. It's just part of the phone number anymore. And I was noticing that today. Somebody was talking about, back when I was a kid, yabba yabba, one of those, nostalgia sites, and
they're losing an essential benefit of recognizing area codes, which is when you look at your caller ID, you have a clue as to what state it's potentially coming from.
Yeah, they have so many of them anymore, and they're getting to be so sparse, so densely packed. I mean, I remember when most of Texas had one area code, and not so anymore. 512 was the area code for Texas. Okay. Anyway, figure out which ones you're going to break up, and it's something that you just have to ask. Am I ever going to use this thing in different places? I would break the phone number up. Probably I would break out the area code, the 3-digit area code, and maybe maybe break it into prefix and the last 4 digits. I don't know. This is just things that you look at. Okay, identify the tables and assign the columns. And here is where they cut through some things. We have identified the 3 entities that we will track, and here they are: vendors, invoices, line items. So an entity is a table. A table keeps track of one entity. And these are vendors, invoices, and invoice line items, the big 3 that we're working with here. Under vendors, I have vendor name, address, city, state, zip code, and phone number. The our book, I believe they took out the vendor fax, vendor web address, vendor contact first name, vendor contact last name. I might put these guys together into one field, vendor contact name. I don't know. It's safer if, when in doubt, break them apart. It's easier to put them back together in a view. So I could build a view that put them together very easily. Got the phone. For some reason, they took out the accounts receivable, and then they added terms and account number as foreign keys. Invoice, and I have those because I can't see the terms field. And the general ledger accounts, I can't see that one yet. We're only working with 3 of them here. Invoice number, invoice date, the terms, invoice total, and they have added the payment date, payment total, invoice due, and credit total, account number. That's added. So the terms, we can't see that table yet. I'm looking down the road. We can't see the account number yet, so I'm saying that. Now, I would get rid of this invoice total like a hot potato. No way I'm going to have invoice total in my database. Invoice line items, invoice number, item part number. Let's see, item part number. Seems like that would be something that would be good to have. I don't know why they struck that one out. Item quantity, description, unit price, item extension, I would definitely get rid of because the extension is the quantity times the unit price, so I don't have to have that. And then they have account number and sequence number. And I'm going to talk about the account number and the sequence number here. This is what they are suggesting. Now, there are many ways that you can build 2 different people will build databases differently. Some of them will be good. It's possible to have 2 different ones that are perfectly good. And then it's possible to have 2 different ones that are really terrible too. The things that make a database good are kind of like asking what makes a car good. There's lots of things everything is a trade-off. And we can't, I believe I brought this matter up before. We talk about invoice sequence. Let me disconnect and connect. I think I connected with Windows. Okay, invoice line items. I'm going to edit top 200 and take a look at it. And we see here that we have the everything here looks, account numbers are pretty good. Invoice line item amount is there. Notice that they don't have some things that aren't in here that I would definitely get in here would be the number of things that you're ordering. It's not that, so an invoice line item, a description, like for example, So this is the invoice. We're sending an invoice to somebody. Okay, so no, this is the invoice is going out to these people. So we're billing these people for monthly access fee. And so somewhere in here, I think that we're going to need how many of these are we selling them? Of course, most of this is for services. So I don't know whether we need that right away, but the main thing that I would look at is these two columns right here, the invoice ID and the invoice sequence. This is a total waste. So the invoice ID comes along, and it's essentially numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And there's no particular reason not to do that. I don't particularly like it. I prefer it being a little jumbled up, but you can set the database to jumble it up but never give you two. But some people also like it when it's in the same order. So if you set in what they call in Access, they call it an auto number. In SQL Server, it's called an identity. So if you make a data type as an identity, then it will number for you. The problem with it is if you don't use a number, so if you start putting a number into a table and you get to the point where you're ready to insert it, but then you throw it away, you never get that number back. But that's okay. It doesn't bother me particularly. So it's not unusual to see 1, 2, 4, 5, 7, 9, 22 in these numbering sequences. If you delete a number, you don't ever get that number back, and you can't go in and insert it. But the main thing that I pointed out here is the invoice sequence is 1. Now, if you look at it, this one right here, so under invoice ID 12, I've got invoice sequence 1, 2, 3, and 4. So I have 4 lines on that one, whoever 12 is. DeCicio's, Kinko's, Office Max, and Publishers Marketing. I have different account numbers, but this guy right here, where I have a split primary key. So the primary key here is the Office ID and the invoice sequence. I can see that if I look at my Object Explorer and I go into my tables and my columns, I see that I have the black key here showing a primary key. I have invoice ID and invoice sequence, and I have 2 things flagged as the primary key. It does not have 2 primary keys. Important point. It does not have 2 primary keys. A table cannot have 2 primary keys. It cannot happen in database. If it does, you got a problem. You're not in the world, you're not in Kansas anymore. Both of these fields together are primary keys. I do not like having a 2-field primary key for several reasons. First of all, it clutters stuff up. I want a single field primary key anytime I can get it. And I'm going to talk a little bit about maybe I can't. If you take my advanced class, we'll see where we've got one of the tables that we'll build. There's no way I can have a single field primary key. I'm going to have 2. Okay, if I have to have it, I have to have it. How can I get around this and not have a 2-field primary key? Well, that's easy, fairly. I simply, go ahead. Somebody's going to answer.
Well, something that just increments or uses the time that it was entered, metadata, like when it was put in input?
Yeah,
or
a timestamp works fairly well. Mm-hmm. Or you could just auto number it. I mean, which is how they're getting the invoice ID, I'm sure. I kind of like I like a timestamp unless it's possible for 2 things to come in at exactly the same millisecond. In that case, it wouldn't work very well. But if you could implement some kind of thing where one of them just waited a quarter second and then you'd have two different timestamps. On the other hand, all I have to do would be I just take the invoice ID, something like the invoice ID, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I got to 11 here, so I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one would be 12. This one would be 13, but the invoice ID would still be 12. This one would be 14, but the invoice ID would be 12. This one would be 15, but the invoice ID 12. 16, 17, 18, and I'm going on. So now I'm at 16, invoice ID is 13, and I keep on going like that. Now, if you think about it, you might not like that as well, because it's not as easy just to look at and see. But if I ask the database, show me all of the invoice sequence IDs, invoice sequence numbers for invoice ID 12, I would get back 12, 13, 14, 15 very quickly. Wouldn't be a problem. Here is an invoice sequence number 347. To which invoice ID does that belong? No problem. Show me the rest of them. Boom. So to a database, that's not going to slow it down a second. It's not even a second is a long time. Slow it down, database. It's not going to be a problem. It's more of a problem having this two-field primary key that I don't need, because the two-field primary key, remember that a primary key has an index built on it. Remember that an index is a very complicated data structure. A two-field primary key basically takes two indexes and merges them together, and now I really have a mess. Now, the computer can handle it, of course, but good grief, if I don't have to do it, I'll never do it, and I don't have to do it here. So I would just have the invoice sequence number would be the primary key. It would start numbering at 1, and it would just increment. That's the simplest way to do it. Simple is many times good, so I would just increment it. And so when I get down here, I'm up in the hundreds, and every time I had a duplicate invoice ID, so the invoice IDs can be duplicated, but it wouldn't necessarily be straight. So it starts off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Up until about here, they're the same, but now they change. So the invoice sequences, I would still have to keep the invoice ID. This is my foreign key that takes me to the invoices. This is the invoice sequence. Questions? That would be a big change. Invoice line item amount. If I had a unit cost in here, so I probably am going to have a unit cost and a quantity in most invoices, and so I would get those by multiplying them together to give me the line item amount. I'm not going to store anything that I can calculate. Questions? For that reason, I would not store the invoice total, because the invoice total for invoice number 12, let's see, is simply the sum of these 4 rows. And because if I store that, number one, I'm wasting space, and number two, I could have an inconsistency. If I change one of these, it's not going to change the invoice total. Well, I could set it up where it would, but the way it is right now, where the invoice total is just money, it's not going to change it. And so that's something that never store a value that you can calculate. And there's a couple of other places I'll point that out. Back to this guy. So I would definitely lose the invoice total. Let's see. Okay, invoice total should not, I put that in red. Do you happen to notice that invoice ID 46 had an invoice total of 224? The problem with it is, I think invoice ID 46 is a I don't think there's a 46. Is there one? 40, yes, there is an invoice ID 46 over in the invoices table. And I think I asked you to find that one. I'm sure I did on outer join, because that one's there so that you'll have something to find. So when you look for an outer join and you're finding a record there, so I've got a record. Now that's a parent, so that's just a invoice ID 46 is just a childless parent, but it's got an invoice total in there, and that invoice total is supposed to be derived from the sum of the line items. So I've got some serious problems, design problems in the database that we've been working with, but this is the time we start talking about them. And hey, what do we do with this? Well, what would I do? How would I fix that? If I've got this problem, I've got my invoice line items over here, and if I go over to my invoices right here, and I look at it, edit it, and I see my invoice totals. And notice I've got a 46 here, and the invoice total is $224. But I don't have any line items for that one. Huh. How would we fix it? Well, one way is go put some, delete it. Yeah, I could do that. It shouldn't have an invoice with no invoice line items. So I guess I could delete it, but there's a problem. And how do I fix that underlying problem? What should I do? What approach would I take? Given that I can get this fixed, okay, I'm going to have accounting look at it and go through it and alter books and figure out what to do with this one particular record. But I flag that record and let management handle that. I'm a database person. As a database person, I want this never to come up. How can I make it not come up again, ever?
Enforce constraints.
Okay, I could put a constraint on it. Now, think of a constraint, and so a constraint has a constraint name. The problem with a constraint is that it applies only within that table. I can't reach out to another table and check some other table. I can check that something exists. So if I have a foreign key, and I try to insert something, I'm going to check it there. So I might be able to do it with a foreign key and make sure something's there, but I can't check that the sum of the invoice line items adds up to 224 in a constraint. That is beyond the ability of a constraint in any database. Go ahead.
I'm sorry, you've got a parent, so this is a parent, I'm sorry, I'm realizing you're in the parent table, so you've got a parent without a child.
Yes.
And you're trying to figure out why the parent has data that should have come from the child.
Yeah, it would be equivalent to if I am a childless parent, yet on my income tax, I'm claiming 5 children.
But didn't you already say that you should have never designed it this way in the first place to take a total in this table? It should only take that total from the child table, which was invoice line items.
Yes, so many times you'll come into a situation like this. And so the question is, well, what do we do? How should we fix it? What are your recommendations?
Can you have this parent table? So when you said you would never include invoice total,
get rid of it.
Just take it out entirely. But I feel like we're kind of on the cusp of what's best for a database versus what's dependent upon the applications you have on top of the database.
Oh, I agree.
And if you have users, okay, because I mean, if you've got users, if you don't have much in terms of application on top, and you're going to have users who are going to look at this and be completely confused, and you've got, Okay.
I can't change the information that's displayed, but how would I display the information? Okay, there's two approaches I can take here. The first one we're going to learn about at the very first of the next class, and that goes to the idea of what's called a database trigger. A database trigger is a program that goes with the class, database programming. So it's a program that executes when something happens. So when you update something, this trigger fires. Now, a trigger can do anything. They're more expensive. But when you change a table, when you change something, I can change 5 or 6 other tables. It's used in logging. So I could set up a trigger. More about that is coming later. But we do know something else that we could do. And do you remember when we talked about database views?
Yes.
Okay. Why not I set up a database view? In my database view, I'm going to base it on invoices. So I might say the view might look something like this. Let me go back to it here. Get me a new query. So select invoice ID, et cetera, et cetera, et cetera. Sum of what was that? Invoice total. No.
Invoice line item.
Invoice line items under columns.
Amount. Invoice line item.
Invoice line item amount. And then I would join these two. I'm not going to sit here and type on it, but sum of the invoice line item, join them, and then when I get this select working like I want it to, create a view out of it. And I would name the view something like, I can't name the view invoices, but I could name it new invoices or my invoices or something like that. I might go ahead and do that, such that if you every time you open the invoices, you get an up-to-date sum of it. Now, the way those guys work, if you happen to have that new invoices open, the view, and somebody changes the invoice line items table, it will not reflect it immediately. And that goes to the idea of we have to lock the tables. If we're looking at it, we can't have those data changing, and we're going to talk about that in the next class also, locking tables such that nobody can change them, which doesn't make you popular if you're in a busy environment. Okay, but nonetheless, that would keep it. If I created a view and the invoice total were not really in this table at all, but is the sum of the invoice line item amounts, then every time I opened it, at least, I would be seeing up-to-date information, and it would stop me from having it. But this guy right here, I would just see 0. Because if I have an invoice that doesn't have any invoice line items, well, the sum is just 0. Okay, the information is accurate. Now, I really shouldn't have an invoice with 0 line items, but hey, why not? Well, I can think of several reasons, business reasons, but I can't think of any database reasons. Okay, let me finish this up. This, by the way, this will be a fairly easy assignment. Relationships and keys. Okay, the relationships. The big ones are the one-to-many relationships. One-to-many relationships are enforced by the foreign key. So the vendor ID to the vendor ID. And I don't know, they put this little crow's foot on one side. Sometimes they do different things with it. For some reason, we used to have a tool that would show these relationships to us, a graphical tool, and I'm sure you're used to seeing them. Tracy, you probably have one. If you have a in Server Management Studio 18.1, they dropped that tool. No, excuse me, 18.0 dropped the tool that diagrams the relationships, and everybody has screamed bloody murder. So 18.1 put it back. So from now on, we're going to be using 18.1 so that we can do that. This comes from that. I would be able to diagram this and see all of the relationships. So this is the vendor ID relates to the vendor ID one to many. This is typically how it's done. Sometimes they'll put a little infinity sign on it. I don't know, it's not infinite, but that's what they'll use. Invoice line items. Go ahead.
I'm sorry, which version dropped it? You
Version
said 18 has it back?
18.0 of the...
18.0. Okay.
18.1, it's back. So it would appear, if you have it, when you go into your database, right at the very top, the very first one under the AP_DB, one of them is, the first one is database diagrams. I was going nuts this afternoon trying to find that. So I finally was, whenever, as I usually do when I don't know what I'm doing, I Googled it and, oh, they took it out of version 18.0, which is what I've got. And I was not amused because I wanted to use it this class period. But I have some I think 18.0 will be like, what was it, DOS 3.2, where they got rid of the 640 kilobyte upper bound, and nobody's program worked. Everybody had to go buy brand new software. So it didn't go over very well. But that's, let me go back, let me finish this off here. Okay, the relationships. So here are one-to-many relationships. One vendor, many invoices. One invoice, many invoice line items. We've been doing this all semester. And invoice line items, I don't like it when it has a double. Notice that the invoice line items, not only does it have a double primary key, but one of those pieces of the primary key is involved in a foreign key relationship. This is really going to come back to bite me on some part of my anatomy sooner or later. Pretty straightforward. Invoice total. I don't have a lot of comment on this one. Okay, I'm discussing the two-field primary key. Now, let's talk about a many-to-many relationship. A many-to-many relationship. So an employee serves on many committees. A committee has many employees. I don't recall whether we have done this one, whether we have talked about many-to-many relationships or not. In my opinion, they should come earlier in the textbook. They're coming a little too late, in my opinion. We should have been doing them kind of all along. I would have put more emphasis on them. Lots of times you'll get them. Now, we don't see very many of them, and we build a many-to-many relationship out of two many-to-one relationships. So notice that when I have a many-to-many relationship, one employee is on many committees, one committee has many employees. One patient may receive many prescriptions. One prescription may be prescribed to many patients, and so on like that. So you have them all of the time. What happens is that a table comes into existence between them. We call this a linking, our book calls it a linking table. Our book mentions it only very briefly, in my opinion, too briefly. I call it a bridge table. But its job is to create this, and I named this one memberships. So the job of this linking table is to link the employees to the committees. Now notice the employee ID comes over to the memberships table. The committee ID also comes over to the memberships table. The employees has a one-to-many relationship with employee ID. The committee ID has a many-to-one relationship. So it comes in as a many relationship, goes out as a many relationship, giving us this many-to-many relationship. Now, there's several ways I can handle the primary key on the memberships. Remember, memberships has to have a primary key. This is one time that I might very well have a two-factor primary key. My primary key might be employee ID, committee ID. I need a primary key on this table. I'm not going to be searching it very often. I don't really care a whole lot if it has a two-factor primary key. If the only job that this guy is doing is keeping track of the memberships, two will be fine. Now, there may be other information. This table might be doing something more besides just simply relating employees and committees. For example, if this were patients and this were pharmaceuticals of some type, what would we call this linking table? That would be a prescription. Now, when you think about a prescription, has quite a bit of information maintained about it. But one of its jobs is to relate the patients to the pharmaceuticals that are prescribed, so it would have this many-to-many relationship in it. It would act thus. It would also have a lot of other stuff. So you can bet in a pharmacy, that database is quite complicated, but one of its jobs is relating the patients to the pharmaceuticals. And this is how it is done. Now, probably the prescription has its own number. I'm absolutely sure it does, a prescription number. So it gets a primary key, gets its own, and that's perfectly legal. You can give it a primary key. I would probably use some kind of an identity, start off with 1, 2, 3, 4, 5, and then these guys are just there. So it would be possible to have a patient is prescribed pharmaceutical aspirin, and then the patient could be prescribed aspirin again later. So it could have its own date on it and all that jazz. I'm sure it has a date. This particular one is a very simplistic way of approaching it. Okay, I'll call him back. Okay. Sometimes tables have a one-to-one relationship. Well, why would you do that? If I have two tables and they have a one-to-one relationship, I could just take that second table and fold it into the first table. There's no reason I can't. If it is one-to-one, for example, an employee has a department for which they work. They only have one department. No, that wouldn't be a good one. What would it be? An employee has one. There's no reason for me to put the first name and the last name in two different tables. It's kind of silly. On the other hand, sometimes I have a one-to-one relationship, and the time I want to do this is when I have a sparse relationship. So it's going to have a lot of null values in it. For example, I don't know how you feel about having your photo, your picture on the web page. Do you think it's a good idea? I'm not
Now-
real excited. And Tracy says no. I'm not real excited about having my picture on the web page. Maybe I will put my picture on the web page if it pleases me, but I don't want my employer posting my picture. I mean, it's just it's mine. Therefore, I would set it up like this. I would have the employee's ID, first name, last name, IQ and shoe size and all that jazz. Oh, that's probably something I don't want in there either. Put it here. And maybe most people don't want their picture. An employee has exactly one picture. A picture applies to exactly one employee, but this one's going to be null. Moreover, the second thing is a picture is probably a pretty large thing, so I don't want this null field in my database. I don't like null fields. So I set it up with a primary key. So employee ID is the primary key of both tables. Okay, notice that I can't have, and then I set it up as this is a foreign key, so it's a primary key and it's a foreign key, so I can't have a photograph of somebody that's not employed here. Employee ID comes over here, and it is only one of these can be in here, so it has to be unique. Everybody has to have one, but not everybody in the employees table has to have a photo. In fact, I'm expecting it when I set it up this way. I'm expecting most people not to. But when I have two tables with a one-to-one relationship, I'm setting them up thus. So a foreign key can become very handy when I have a relationship that, for the most part, it's going to be one-to-one. But if I have one, I only have one. So if you have a photograph, you only have one photograph. But most people aren't going to have one. Anyway, probably a better example, but I like that one. Okay, first normal form, apply the first normal form, access by content only. Remember, we can't have top. So if you're in first normal form, that rules out using top. Do we do it? You better believe we do it all the time. Do we break the rules? Yes, we break the rules. There can be no duplicate rows. I don't almost never break that. The primary key will enforce that. So if you have a primary key, you're pretty well cool on that one. I don't like queries running that access that talk about top 10. You'll almost never see me write a top query, and all fields must contain a single value. Now this is subjective. If I have somebody's name, for example, I once had a cat. Well, I have cats, but I had my cat's name was Feed Me. Okay, so that's 2 words, Feed Me. Should I have stored, if I were making a database of my cats, I don't have that many, but what would I store that in two different fields? No, because I see it as one value. If I'm storing my friends' phone numbers, I might store my friends' phone numbers all in one field. I have one text field. I put my friend's phone number 1, phone number 2, phone number 3. I just put them in there as a list, and then when I want to find them, I go in there and pull up that field, and I know which one's which. So to me, it is all one value. So they contain a single value. For table being first normal form, get rid of it. So contains repeating values. Here we go right here. VB adds SQL library. So the item description is clearly repeating. This one I'm going to pull out. Goodness gracious, I'm out of time. First normal form. So we have broken it out. And then I added in the key, 1, 2, 3, 4, 5, 6. I hope this is clear because I'm going to need to move on here. I guess I could go some into next period. Second normal form. Second normal form says when I added the keys, Second normal form, every column must depend on the key. So every column that is not a key must depend on the primary key. So let's see, for example, I can't have, that rules out the idea of having invoice number being repeated. No, it doesn't, does it? What here is, so the vendor name and the invoice number together. Okay. Invoice ID. So we got invoice number 1, 2, 3. So this guy is essentially a key. So let's put it together here. We pull out the invoice number. The invoice ID is the key. And the invoice number may or may not be unique. Invoice ID takes me over here. I have invoice sequence and item description. So now I am in the second normal form. So I have the first normal form. I always say, remember it this way. First normal form, you get a key. Second normal form, you want everything to depend on the whole key. And then the third normal form says nothing but the key. And you don't always go to third normal form. So here we are in third normal form. I'm going to go ahead and wrap up tonight because I told you I would get done by 7. I'm going to come back and finish this off on Thursday. Notice something about this one, though, that the terms table, the terms has its, where was it? No. Oh, see, the invoice line items. Invoice line items table has a relationship coming in that is 1 comes into many. It has another relationship from many to 1. So the invoice line items table actually creates a many-to-many relationship between invoices and the GL accounts, the graphical ledger, the general ledger accounts, based on the invoice ID and the account number. So from one invoice ID, I can have many account numbers. With one account number can be associated with many invoice IDs, and they're associated thus through the invoice line items table. And I'm arguing with our author here. So I'm going to go ahead and let you guys go tonight, and I will wrap this up. Oh, here's the key, the whole key, and nothing but the key. So help me, Codd, C-O-D-D. Codd was a computer scientist who came up with the idea and who developed, he was an Australian, who developed the relational database model of the foreign keys and all that. So Boyce Codd, he was a very important person, but we have this saying that we said the key, first normal form, the whole key, second normal form, and nothing but the key. And these ideas of the normal forms, I'm going to put them out as this is something we'd like, but we don't always go all the way to it. Sometimes it is more trouble to get there than it's really worth. See how much else I got. Okay, so it's got the quiz. Now, when you decide to do the exercise, chapter 10 exercise, so there's a Word document. We will do this one as either as a Word document or a pencil and paper. When you turn it in, you will turn it in here. You may turn it in as a Word document. In other words, you may draw it using your drawing tool. You may print it out and you may draw it. Please make it look as neat as you can. You may draw it and draw your relationships with a ruler and a pencil. And then you may either scan it in, or you may take a good picture of it. In other words, a photographic scan, and you can attach that. So I'm not holding you to. You can attach any kind of a file here and hand it in. I suppose that well, in the past I've accepted pencil and paper handed to me, but since I will never see you and I live in Denton, that probably isn't going to work. So get it somehow into a digital format. And basically you're going to, for orders with 4 tables, you may change the tables some. So I have customers, I have orders, order line items, products. So COP, this is known as the COPS database. So customers, sometimes it was customers, agents, products, orders, and we, I had a professor once that he used it CAP, customers, agents, products. And I said, that's the CAP database. I said, well, how come you don't call it the CAPO database? And he was from Boston, and he explained to us that a capo was a mafia boss in Boston. Okay. Now add these 2 tables in. You may create additional tables if it works. So you're going to make some decisions about these, how this will be used. In other words, it's kind of like writing an essay, I guess, more than it is doing data. You don't have to run it. You don't have to develop SQL code and make it work, although you might want to try that and see how, creating the tables. I don't want it to get that tedious necessarily. Basically, this one is just, I want you to design it and come up with something that in theory will work. Am I making any sense at all?
Yes.
Good. Okay. Well, in that case, I'm going to come back to this and finish up the 3rd normal form on Thursday. And then on Thursday, I'm going to bridge a little bit into the next class, and I'm going to talk just a little bit about programming. I'm not going to have much time, so I won't be able to go very deeply into it. But we have a full programming language here that we can do just about anything in. And I'll probably just wrap up on Thursday, wrap up this class and say sufficient unto the day is the evil thereof. So the final will be, I only have 1 day to give the final. I'll probably make the final available on the weekend, Saturday or Sunday. The final will be optional. That means that you may choose not to take it. Now, if you take it, you're going to get the grade. Okay, so if you take it and you say, I don't want to do this, then don't submit. If you submit, I'm going to grade it. Are we clear? Yes.
Yes.
Okay. Okay. So if you choose not to do it, don't do it, because if once there's a submission, then I have to put a grade on it. All right. Okay. Go ahead.
So that means don't open or start the multiple choice part, because that we don't submit. But once we open it, it's started, right?
Yeah, if you want to open it, you can go ahead. Oh, on the multiple choice. I'm not real fond of multiple choice. It's kind of a, I went through them and made them a little bit better than the exercises. Yeah, just if you're not going to take it, just don't take it. Okay. Hopefully hopefully it will increase your grades. But if you're already happy with your grade, then don't worry, be happy. Okay. It's 15 minutes past the end of class.
I realize it's really kind of a lot to ask, but when do you think we'll have test 2 grades?
Oh, I did talk about that just before you got here.
Oh, I'm sorry.
Yeah. Tomorrow, I will, by close of business tomorrow, I will have them all posted.
Okay, thank you. Sorry, I was
yeah.
a little late.
No, that's fine. I'm going to get up in the morning, and so that because grading tests, it takes me a good part of a day to grade a class's worth. So I'll get up in the morning and get started on them, and before I go to bed at night, they will all be graded. So I will have all of the grading caught up tomorrow.
Thank you.
Mm-hmm.
And we'll cut you slack. That's a lot to ask in one day.
Well, I need to get it done because that's why they pay me $5 an hour.
Yeah,
Okay.
I understand.
I'm gonna. Anybody else comments?
Thank you.
Thank you. Others? Okay, I'm going to end the meeting.
Have a good evening. Thank you.
Likewise.